Welcome back to today's video. In today's video, we're going to discuss how we can fine-tune our random forest regressor model using grid search in order to determine what our hyperparameters are. Before you end today's video, make sure you hit the subscribe button down below and like the video for more content just like this. All right, let's take a look here at what the grid search is. Remember, in our last lesson, we were implementing a random forest regressor model, and we discussed what a random forest regressor was. Remember that it used several decision trees in order to create predictions using particular parts of the data, bootstrapped data, and certain features in order to develop predictions. From those predictions, we were able to take either a majority vote, we were able to take an average, we were able to take if you remember, a probability voting in order to determine which prediction we wanted to choose. And we talked about how that helped prevent overfitting the data. It allowed us to use certain parts of the data rather than using all of the data at once in order to create our model. Now, in today's lesson, we're going to decide how we can decide what our hyperparameters are. And by the way, I should say that in the last lesson, we were unable to finish executing this cell. And when we execute the cell, we do end up with a output of 49,000 for our error. So we have an error rate of $49,000 from what the expected value of the house price is compared to what the house price actually is, which is much better than what we had previously, since we are using a random forest. Although that being said, our random forest that we built in the last lesson had no parameters being taken in. We basically just had a random forest with with just the default hyperparameters. But we want to be able to decide what those hyperparameters are. So let's take a look at this here, how to implement a grid search. So remember, we're going to discuss what a grid search is. A grid search is simply a way for us to run several tests using cross-validation in order to select what are the best hyperparameters. And we can run through several different hyperparameters that we can choose. Grid search is a part of fine-tuning. So what is fine-tuning? Fine-tuning entails basically taking a model that we already have and making a better model, or maybe even replacing it with a better model for our data. So one of the things you can do is adjust hyperparameters. We can also do feature engineering, meaning that we can normalize the data. We did do some feature engineering in the past. We did normalize the data for our features. We can add additional features. That's also something that might be useful in case we don't have enough features to correctly predict. We can also do data preprocessing, remove outliers from the data, fill in missing data. We were able to do that using the simple imputer module. So we were able to do some of these already. Another one is model selection, deciding which model we're going to use. We can go linear regressor, decision tree, random forest, which one we want to use. Another one is a training strategy. So we can determine what's the size of the training set to the test set, right? Sometimes we want the training set to be 30% of our overall data. Our training set's going to be 70%, et cetera, et cetera. So those are different ways that we can fine tune our models. And grid search is one of the ways that we can do that by adjusting our hyperparameters. Now, if you want to know more about what hyperparameters are, go back to our tutorial number 5. We discuss what hyperparameters are. So GridSearchCV is a built-in model in the model selection module in scikit-learn. So in the model selection library, we can import the GridSearchCV GridSearchCV class. And what we're going to go ahead and do to begin with is let's go ahead and take a look at our random forest regressor. Okay, so I believe we printed it out here. I think it's at the bottom actually. So let's take a look at our random forest regressor. There are several different hyperparameters that we can select. So there's several different hyperparameters that we can select. You see here that we have n estimators. N estimators is one of the ones that we're going to be looking at today. One of the hyperparameters we're going to be taking a look at. So let me go ahead and open up the documentation for this here for n estimators. N estimators lets us set the number of trees in the forest. So within our random forest, remember that we can have a certain number of trees. In the example we looked at in the previous lesson, we discussed how we had 4 trees in our forest. Now, by default, we're going to have 100. So by default, when we ran it in the last tutorial, we had 100 trees in our forest. Now, typically speaking, you're going to have very many, although we're going to be deciding how many we're going to want to have by using our GridSearchCV. So that's an important parameter that we can set. Another one would be max features. So max features, let me pull up the documentation here. Max features tells us the number of features we should consider, tells the model how many features we must consider when looking for the best split. So remember, when we're deciding what our splitting mechanism is going to be, we have to look at certain features that the model is going to decide, and we can tell you can only look at a certain number of features. Now remember, the way the features are selected is without replacement, without replacement, meaning that each of the features for each of the individual splits will be unique, and we discussed that in the previous tutorial. Now you see here that we can basically input our features as being integers, floats, square roots, log. We're going to be concerned primarily with integers, and we're not going to get into the other ones. But if we give it an integer, then it'll tell us how many features we can consider at max in each split. And remember, the features are simply the input variables coming in. So in our case, we have, I think, 8 or 9 input variables coming in to our model. We want to predict what the median house value will be. So we're going to have two, we can have as many as we want. By default, it's going to be equal to 1. Okay, by default, it's going to be equal to 1.0. So only taking a look at one feature there. All right, and so there's many others there. You see here that we can also determine the max leaf nodes. So max leaf nodes, if I were to just open that up there. So max leaf nodes, it tells us how many leaf nodes we can have at max. Many of these are very self-descriptive. So remember, when we're creating our decision tree, let me pull that up there very fast. When we're using our decision tree, we have leaf nodes. So in this case, we have 4 leaf nodes. Remember, leaf nodes are simply pure nodes. It occurs when we're able to bring the data and bring it down to just one particular type, right? Bringing the data down to exactly one type. And so it's going to determine how many maximum leaf nodes we can have. So that's very important there. There's many others here. You're seeing here max depth, right? How many layers you can go down, you can have there. So let me just pull that up very fast just to show you guys the maximum depth of the tree there. If none, then nodes are expanded until all leaves are pure, or until all leaves contain less than min samples split samples. So in this case, if you don't specify it, which is what we did in the last lesson, we didn't specify this variable, it's simply going to go as basically as low as it can go until all the leaves are pure leaves, obviously, until you have only one data type, or until we contain less leaves than the min sample split samples. So there's another parameter that basically says how many minimum splitting we can have. So how many minimum splits we can have in our decision nodes, basically how many nodes we can have, decision nodes. So we either go until we have pure nodes or until we reach that's the parameter there, that hyperparameter. Okay, so there are several different parameters that we can select. All right, so how are we going to be selecting these parameters? Well, one of the ways we can do them is simply by inputting parameters, seeing what the output is going to be like. That is obviously going to be very tedious. Grid search allows us to be able to run through many different tests using cross-validation, which, remember, cross-validation, we have a certain number of basically data sets that we want to split our data into. So if we have a data set, we're going to split it up into basically 10 sections. And then we're going to go through basically 9 of those sections and use those 9 sections of our training set as our training data, and use the last set as being our test set. And we're able to go through them each time using a different training set. All right. And so we're going to be using cross-validation. So how are we going to create our grid, right? How are we going to create our parameter grid? So here we see here that we have n estimators, and we're telling that you can either have 3 estimators, 10 estimators, or 30 estimators. So in this case, we're saying either the random forest is going to have 3 trees, 10 trees, or 30 trees. And then we have max features. So max features is telling us how many maximum features can we have for each split. So you see here we have 2, 4, 6, and 8. Remember by default, it's going to be 1. And so we can determine that. Now the question is, for just this one dictionary that we have right over here, how many total times is the model going to do its work? Well, in this case, we're going to go through it 12 times, because for each of these, we're going to go through every single one of these max features. So when we have 3 trees, we're going to say, okay, at 3 trees, we're going to have a max feature of 2. At 3 trees, we're going to have a max feature of 4. When we have 3 trees, let's try to have a max feature of 6 for our splitting mechanism, and so on and so forth. And so if we were to use the fundamental counting principle, we're going to say 3 times 4 is going to be equal to 12. Okay, so we're going to have 12 different individual tests there. Okay, now by default, bootstrap is going to be equal to true. Remember, bootstrap simply says that whether or not we're going to use the entire data set, or whether we're going to do it, we're going to select the data, select our individual data sets with replacement, with replacement. So let's take a look here at the documentation very fast. Bootstrap, by default, it is going to be equal to true. It determines whether bootstrap samples are used when building trees. If false, then the whole data set is used to build the tree. And so I believe we had that in the previous, in one of the slides, in one of the images here. So we saw it here. This was selected, these samples were selected via bootstrapping. And so we selected each of these rows by doing it with replacement, which is why you're seeing that some of these rows are repeated, some of these samples are repeated, because once we take one of the samples out, we put them back into the data set. But now that we're setting this equal to false, if we set it equal to false right over here in our second dictionary, in our second experiment, what we're going to see is that we're going to use the entire data set 0, 1, 2, 3, 4, 5, each of those IDs, instead of simply taking one out randomly and then putting it back in, taking it out, putting it back in. And so that's one of the things that we're going to test there. That's the reason why we have a second dictionary. And so the same thing with this one, we're going to have n estimators 3, so 3 trees. For 3 trees, we're going to test it under 2 max features for each split, 3 max features for each split, 4 max features for each split. And so in this case, you're going to have 6 individual tests. Okay? So I hope you understand how this param grid works. From there, we're going to create a forest regressor using all the default parameters, right? And then we're going to go ahead and create a grid search. We're going to pass in our random forest regressor, and then we're going to pass in our parameter grid. Now, our parameter grid is going to allow us to go through each of these tests individually. So it will be setting the hyperparameters. So it's going to be going one by one, and it's going to say n estimators equals 3, comma max underscore features equals 2. And it's going to go through each of those cases one by one. And we're saying here for our cross-validation, split it up into 5 individual samples. So we'll go ahead and do that. For our scoring mechanism, we're going to use a negative mean squared error. So a negative mean squared error. And again, the equation for that there, just remembering that there, we take the value that is expected minus the value that we actually got. We square that value to get rid of negative numbers. From there, we divide it by the number of instances, and then we take the square root to counteract for the fact that we had to square it. Okay, and we're able to get the mean squared error from there. And then we're gonna basically multiply that by a negative. And the reason why we're gonna multiply that by a negative is so that way we know that as the values become bigger, it becomes better, right? Whereas as the values become smaller, it becomes worse. And so that's our scoring mechanism. And then what are we going to be returning? Well, we're going to be returning the training score, and we will set that Boolean equal to true. From there, we will call the fit function, which is going to find our relationships in our data. All right, from there, let's go ahead and run that. And we've already run that. So I'm just going to tell you that we already ran that. And the reason why I'm already running it ahead of time is because of the fact that this is going to take a very long time, actually. Because remember, we're doing a cross-validation of 5 for each of these instances. So here we have 12 that we're going to do, 12 different individual grid searches, right, for our random forests. And then you're going to have 6 over here. So in total, it's 18. And then we're going to split the data 5 times, which means we're going to go through that individually 5 times, which means in total, we're going to go through this process 90 times of creating a regression model. So basically, that's a very long time, right? Sorry, not 90 times, actually 18 times. But we're going to split the data in 5 times individually, right? And so because of that, it's going to take a very long time. So I just went ahead and ran that. From there, once we finish that process, in that fit function, we will be setting certain variables. So one of the instance variables that we'll be setting is the best underscore params. So the best underscore params are the best parameters that the model has decided that we should use after running all those tests. So after running all those tests, it is determined that using a max feature of 8 and an n estimators of 30, that's going to be our best. And it doesn't mention bootstrap, and the reason for that is bootstrap by default is equal to true, so we already know it's true, okay? So in this case, it's going to be 30 n estimators along with 8 max features. Now, one of the things that you might be looking at here, and you might be thinking, we have done 8 max features and 30 n estimators. So that kind of makes sense, right? Because as we get more and more trees, we would expect our results to get better, right? As we increase the number of features that we use for each splitting decision node, we expect our results to get better. right? And so you might be considering that as well, and we will talk about that in hopefully the next tutorial as well. Okay, now if you want to get the best estimator, just get something that you can use later on in order for you to actually run that. We can print that out, and when we print that out, you see here that we have selected these here in our random forest. So you see here we got n estimators is 30, max features is 8. And all the other values, by the way, are just set to their default values. Okay, all the other different hyperparameters are set to their default values. Okay, from there, what we're going to go ahead and do is we can actually go through each of the individual results. So after we went through each of these individual results, which in this case is going to be 18 results, we can say CV underscore results, cross validation underscore GridSearchCV underscore results. When we do that, we can see each of the results for each of the individual tests. Now, what the model is going to, what the best underscore param is going to do, it is going to choose the one which is the least worst option, right? The one which minimizes error as much as possible. And so that variable is stored right over here. And then from there, we're going to loop through the mean score and the params, so the individual parameters in this case. So basically each of these right over here. And the mean score is going to be the number right over here. Now the mean score, we basically calculate that using this equation right over here. So we calculated using that equation. That is the mean score. So the mean score, remember, is how off our actual value is to our predicted value. So keep that in mind there. And so from there, we're going to go ahead and take the square root but multiply it by a negative. And the reason why we're going to multiply that by a negative is because, remember, our value is done using a negative mean squared error. And so we multiply it by a negative in order to get it back to a positive. And so we're going to print out the params as well, so the individual parameters. So you see here what the parameters that we're going to use. And so when you look through all this data, remember, we want to minimize the mean squared error. And so because of that, when you look through, you want to get the lowest value. And you notice here that it should be 49,000, I believe. Yeah, right over here. Yeah, right over here. So yeah, 50,997. That's the lowest error that we can get using each of these individual hyperparameters. Now keep in mind, does this mean that we have optimized it to the best parameters possible? Obviously not. The best way to do this actually, as far as within the framework that we're currently in for now, the best way to do that would actually be to list obviously every single individual parameter and then give it an even wider range of values that we can choose from. So instead of choosing from just 2, 4, 6, 8, we have to choose from 2, 4, 6, 8, 10, 20, 30, maybe all the way up to a very high number. For an estimators, we should go maybe at least above 100, right? Since the default value is 100. But this is something that we can use. Obviously, we can use more parameters in order to minimize error even further. But all of this comes into play in fine tuning. So we'll be going over more of this in future lessons, how exactly we can fine tune our model. For now, we got into a bit of an introduction how to use the GridSearchCV class within the model selection library. If you like this video, make sure you subscribe button down below and like the video, and I will see you in the next video.